If we have a light source that is in one type of medium, in this case air, and we're pointing this source towards a boundary between air and water, then when the light strikes this boundary, you're going to have some reflection, a little bit, but the majority of the light is going to go through into the water. But it's not going to go straight. It's going to go at a different angle. And so what you find is that when we talk about this angle of incidence, this angle here, theta 1, it's in reference to the normal to the surface of the water and air. Then you'll notice that the light ray bends towards this normal in the water. Now, if you put the light source in the water and shine it out at some incident angle, normal to the surface, you're going to get some reflection back into the water, but you're going to get some transmission through, and its angle based on the vertical normal to the surface, theta 2, is actually going to be greater than theta 1. So this leads us to Snell's law, which basically says that the refractive index of the first medium times the sine of the angle that the light makes with the surface and the normal is equal to the refractive index of the second material or medium times the sine of the angle with respect to the normal to the surface. So we can now find these angles based on the refractive index, and depending on which way we go from either a lower to higher refractive index or a higher to lower refractive index, we will be able to tell exactly how these light rays will respond to these different boundary conditions.